Task 2: Modeling of the knife roller. Hello, everyone. In this lesson, we will learn about the modeling of mask roller press. The modeling of the knife roller is used to cut the mask cloth roll into shapes so that individual masks can be separated from the cloth roll. Next, I would like to ask everyone to think about the meaning of a poem. The mountain becomes higher for accepting every dust. The ocean grows bigger for welcoming every stream. It means, Mount Tai does not reject the soil, so it achieves its height. Rivers and seas do not reject any small streams, so it achieves its depth. It shows that only by grasping every small detail in doing things can you accumulate great achievements. This sentence inspired us that as future mechanical engineers, we must have quality awareness. Following standards and paying attention to details are the keys to success or failure. Therefore, during the modeling process of parts, we must pay attention to and control details. Through drawing analysis, we divide the knife roller into the following parts. 1. Cylindrical roller. 2. Blade teeth. 3. Drive shaft. 4. Keyway. 5. Transmission joint. For each component, our proposed modeling approach is as follows. 1. Cylindrical roller. Constructed by cylinder. 2. Blade teeth. Constructed by sketch, wrap curve, split surface plus offset, and chamfer. 3. Drive shaft. Constructed by cylinder. 4. Groove and keyway. Constructed by keyway. 5. Transmission joint. Constructed by sketch and extrude. We will divide the content of knife roller into 2 parts for explanation. In this lesson, we will study the first part. Next, we will open the UG software and go through the modeling process of reading drawings, drawing, correcting errors, refining to master the method of the modeling of the knife roller. Please pay attention to cultivating the professional qualities of precision, diligence, standardization, and innovation. Open UG. Let's start the modeling of the knife roller. Click on New. Select Modeling Method. Name it the knife roller. Choose your storage path. Click on OK. In web browser, drag the picture of the knife roller in. Zoom in. Take a look. This is an unfolded view of a knife roller. It has a 2-digit size. We go to Preferences here in Menu. Sketch. Change the size label of the sketch to value. Continuous auto dimensioning. Check to cancel. Press OK. Then find the dimensions from Preferences mapping here. Size down. Find the text. Change decimal to 2 digits. Click on OK. OK, let's start modeling the knife roller now. First, let's draw the cylindrical shape in the middle of the knife roller. Click here for more. Expand. Select how cylindrical commands are built. Vector direction here, choose horizontal X direction. Specify the location of the point. We want to place the origin of the coordinates in the center of the knife roller cylinder, so the point is half its length. This cylinder in the middle of the knife roller. Its length is 227 minus the length of the left section 26. Subtract this section on the right is the length of 56. That's 145 of them. Diameter 75 in terms of the size of the drawing. And the knife roller needs to be wound at a height of 2.25 on one side. Then the wrapping diameter will be 75 plus 4.5 is 79.5. Then specify the location of the point is half the length of the cylinder. Select -145/2 in X direction at the specified point position. Click on OK. Look at the cylinder shape. If there are no errors, click OK. Next, we need to draw a sketch of the unrolling of the knife roller. Click on Sketch. Select Default XY plane. Click on OK. Lay out the unfolded view of the knife roller so that it is placed vertically. Tap the keyboard F8 to align. And then we go through the profile. Draw the basic outline first. Start from center datum. There's a slash here. Slash up and slash again. Here's a slash. There's an arc here. We'll ignore it. Where the arc is rounded. Because in a moment this arc can be realized by chamfer. Cancel it first. Elongate this line first. Approximately to the lower half of the cylinder. But don't align the position. And then we go through profile. Draw the line below. Here's a section. Draw a line from here. Remove excess lines by quick trim. Put the shape of this part on the left. Mirror to the other side by mirroring the curve. Select line mode as single. Select these 4 lines on the right. The center line is the x-axis. Then click on OK. After the rough shape of the unfolding diagram is drawn, we have to position it and qualify the size. Click on Rapid Dimension. Size of the top 2 dots. Find out through the drawings that this is 206. Middle. The angle of these 2 lines is 84 degrees from the drawing. The angle of the top 2 lines is 159 degrees. Two side margins. Its angle is 26 degrees from the drawing here. This line to this line. It's 20 centimeters over here, where the overall height is 130.4. From here this is 130.4. The topmost point to the origin of the center of the coordinates. Measures 65.89. At this point, the sketch is fully constrained. But at this time, we also need to draw the arcs of our 102 and our 60. Select arc. The filter selects point on curve. Light up here. Pick one of these. Draw an arc of 102. Make our 102 arc tangent to bottom line by default. And then where the arc and the line intersect. Lead a rounded corner of our 60 from here to here. This is a rounded corner of our 60. Remove excess lines. Now, the sketch requires 3 constraints. Let's take another look at this line. It's still in a state where it can move. We need to size this spot. You can do this by annotating the dimensions. Align the bottom line to the edge of this cylinder. That's 79.5/2. The diameter of this line was not marked just now. Let's mark the size of it. The size here is 102. Okay, by this point, the right-hand sketch is fully constrained. Let's mirror this wire again. Find Mirror Curve. Choose this line. Find the mirror center line y-axis. Remove excess lines. Now the whole sketch has been completely restrained. If we reverse the corners at this time, it will break its full constraints. So we're going to do a new sketch. Finish sketch. After completing the sketch, in a few moments we will wrap this line around the cylinder. For the convenience of winding, let's make a plane first. Click on the plane. Select the cylindrical surface first by means of automatic judgment. Then select the XZ plane, that is, perpendicular to one face of this cylinder. And then we can go through the alternative solution. Move it up by default. Offset to 0, click on OK. And then we create a new sketch. Project this curve into this sketch. Click on Sketch. Select the datum plane just created. Click on OK. Find Project Curve. Choose Connected Curve. Select the outline of the sketch just now. Click on OK. Project the sketch onto our new sketch plane. Click F8 to straighten. By the way, we've hidden the sketch from you. The sketch is now in a fully constrained state. We can do the rounding at this point. Click on Edge Blend. Rounded to our 4. Put these two edges, and these two rounded corners. OK. Rounded corners are finished. Finish sketch. The sketch is in a fully constrained state. The width of the knife roller teeth is 1.5 on the figure. We need to offset this line by 1.5. Locate the curve toolbar. Offset curve is found here. In Offset Curve, enter 1.5. In the Curve selection box, by automatically judging the curve mode, select the curve just now to offset it inwards. Select Inverse Offset 1.5. Then Associate by default. Click on OK. The preferred line, as well as this original sketch line, serves as our knife tooth line. Wrap around the cylinder. We find the Wrap curve on the Curve toolbar. Insert found in menu. Derived curve. Wrap. Select wrapping method. The curve to be wrapped is the sketch line and the offset line. The way we use connected curve. Select sketch lines and offset curves. Select it in the selection area in the second step. The wrap face is cylindrical surface. Position in the palm. Select the datum plane just created. Let the wire wrap around the cylindrical surface. Then click on OK. Take these original sketches and curves. Hide. Curve wrapped. We can use it to divide cylindrical surfaces. From Home here, expand more. Find Split Surface. Click on the selection surface. OK, the object selected is the thread that was just wrapped. Then defaults to perpendicular to the face. Click on OK. Click OK to hide this plane. Locate the offset region in the synchronous modeling toolbar. The height of the knife teeth we see from the drawings is 2.25. Then the entire cylindrical surface is going down 2.25. Select the side that needs to be lowered. The two sides descend in opposite directions 2.25. By reverse. Then click on OK. And then here, the basic shape of the knife teeth is done. Select Edge Blend. Distance is half the cutter tooth, that is 0.75. Select the left and right edges of the knife teeth. This side and this side. Ignore pop-up alerts. Click on OK. Build the knife teeth out. This is the creation of the first part of our knife mold. In this lesson, the modeling task of the knife roller in Part 1 is completed. Have you learned it? Please answer the following questions. This is the end of this lesson. Thank you.